Your Ford left the factory with a hidden countdown timer built into its software, and right now, it is quietly cooking your engine from the inside out. As a technician with over 15 years on the shop floor, I have torn down hundreds of EcoBoost and Coyote engines that were completely bricked before hitting 80,000 miles. The owners did nothing wrong. They changed their oil, used premium fuel, and followed the manual to a T. But what Ford doesn't tell you is that their standard factory settings prioritize EPA fleet averages and marketing gimmicks over the actual physical lifespan of your vehicle. We are talking about a $40 electronic strategy that saves pennies at the pump while engineering a catastrophic $8,000 mechanical failure. I see it every single week. Spun rod bearings, warped cylinder heads, and stretched timing chains, all entirely preventable. If you think your truck is safe just because the dashboard is clear, you are falling into the exact trap the dealership wants you in. Let's expose what is actually happening behind your grille. The first and most destructive culprit hiding in your factory settings is the auto start-stop system. You know the feature. You pull up to a red light, the engine dies, and the cabin goes dead silent. Ford pitches this as a green, fuel-saving miracle, but on the shop floor, we call it an engine killer. In a standard driving cycle, a traditional engine experiences about 50,000 start-stop cycles over its entire lifetime. With this factory setting enabled, that number skyrockets to over 500,000 cycles. That is a 1,000% increase in mechanical stress. Here is the mechanical reality your manual leaves out. When your engine is running, the oil pump creates a pressurized hydrodynamic film of oil between the crankshaft and the engine bearings. Your crankshaft is literally floating on a microscopic cushion of oil, preventing metal-on-metal contact. The second that engine shuts down at a stoplight, the oil pressure drops to zero. Gravity takes over, the heavy steel crankshaft settles, and that protective oil film drains away. When the light turns green and the engine cranks back to life, the internal components grind directly against each other for a fraction of a second before oil pressure can re-establish. You are subjecting your main journals to premature wear hundreds of times a day. Over time, this constant metal-on-metal friction creates microshavings that contaminate your oil pan, leading to a sudden loss of oil pressure and a destroyed bottom end. The fix isn't just pressing the dashboard button every time you get in, because the computer resets the second you turn the key. You need to permanently disable this logic using an OBD2 module programming tool, or a hardwired bypass switch behind the switch pack. The second hidden danger is the factory-programmed 10,000-mile oil life monitor. This is a corporate marketing metric designed to lower the advertised cost of ownership for fleet buyers, and it is an absolute lie. If you wait until your dashboard says 0% oil life, you are pouring liquid sandpaper through your valve train. Modern turbocharged EcoBoost engines utilize direct injection, which inherently suffers from fuel dilution. Tiny amounts of raw gasoline blow past the piston rings during the combustion stroke and enter the oil pan. When gasoline mixes with your engine oil, it breaks down the oil's viscosity and shears the protective additives. By the time that oil hits 6,000 miles, it has lost its ability to cushion the heavy load on your timing chain links. The chain begins to stretch, throwing off your camshaft synchronization and eventually causing the pistons to smash directly into the valves. I have personally inspected chains that looked like wet noodles at 70,000 miles, entirely because the owner trusted Ford's 10,000-mile factory setting. Throw that factory monitor out the window. If you want your engine to survive, change your oil every 5,000 miles or 6 months max, and use a high-quality full synthetic that can resist fuel shear. Then we have the factory transmission shift logic on the 10R80 10-speed automatics. If you own a modern F-150 or Ranger, you have probably noticed a harsh clunk when shifting from third to fifth gear, or a sluggish hesitation when you step on the gas. This isn't a mechanical defect in the clutches. It is a direct result of Ford's aggressive adaptive shift programming. From the factory, the transmission control module is programmed to skip gears, often shifting from first straight to third, then to fifth, to keep engine RPMs as low as possible for fuel economy ratings. This constant gear skipping forces the transmission clutches to slip excessively to smooth out the massive RPM drops between gears. This excessive slippage generates intense localized heat, which cooks the transmission fluid and degrades the valve body solenoids. Even worse, the adaptive learning software tracks your driving habits and constantly alters fluid pressures. If the software miscalculates due to a sudden change in driving style, it causes erratic pressure spikes that physically scar the internal aluminum valve body passages. Once that valve body is scored, the transmission cannot hold correct pressure, leading to total internal failure. To stop this rot, you need to clear the factory adaptive transmission tables using a diagnostic scanner and reprogram the module to utilize a linear shift pattern that treats every gear with respect. Finally, let's talk about the factory active grille shutter settings. Ford installs motorized plastic blinds behind your front bumper that close up at highway speeds to reduce aerodynamic drag. The theory sounds great. Closed shutters mean better airflow over the truck and a tiny bump in fuel mileage. The dark reality is that these shutters turn your engine bay into a high-pressure oven by choking off the ambient airflow to the radiator and intercooler. The factory settings allow engine coolant and intake air temperatures to climb to the absolute limit of safety before the shutters are commanded to open. For a twin-turbo EcoBoost engine, high intake air temperatures are poison. Hot air is less dense, which forces the engine computer to retard ignition timing to prevent destructive engine knock or pre-ignition. This heat soak breaks down plastic vacuum lines, bakes wiring harnesses until they become brittle and crack, and accelerates the degradation of your coolant hoses. You think you are saving a gallon of gas, but you are actually cooking your cylinder head gaskets. The solution is simple. You can manually remove the shutter blades or use custom tuning software to command the shutters to remain 100% open at all times, ensuring your cooling system actually gets the air it desperately needs. You see, the factory settings on your vehicle are not optimized to make your vehicle last 300,000 miles. They are engineered to get the vehicle past the powertrain warranty period while satisfying government regulators. The difference between a truck that ends up in my scrap pile and one that runs forever comes down to recognizing these hidden programming flaws and correcting them before the mechanical damage becomes irreversible. But these 4 settings are just the tip of the iceberg when it comes to the hidden vulnerabilities built into modern platforms. And there are far more critical factory traps we need to uncover before your next drive. We just unmasked how factory gimmicks like auto start-stop and choked-off grille shutters are slowly eating away at your hardware. But those system settings look like minor maintenance headaches compared to the silent killer we need to expose right now. There is a second, deeply buried factory calibration inside your Ford's engine control module that makes every other failure pattern look like child's play. If the auto start-stop system is a slow mechanical leak, this setting is a ticking thermal time bomb. I am talking about the factory-programmed catalyst over-temperature protection delay, paired with the way your engine relies entirely on a single, fragile feedback loop to manage its fuel mapping under heavy load. When this software logic collides with a degraded component, it doesn't just cause premature wear. It triggers a literal chemical meltdown that can turn your entire exhaust system into a solid block of fused material in less than 15 minutes. To understand why this factory setting is the ultimate engine kill, you have to look at what happens when you ask your Ford to do actual work, like towing a trailer up a grade or accelerating onto the highway. Under normal, light throttle cruising, your computer forces the engine to run at a strict stoichiometric ratio of 14.7 parts air to 1 part fuel. This is the factory's sweet spot for emissions. But when you bury your foot in the throttle, combustion temperatures inside the cylinders instantly skyrocket past 1,600 degrees Fahrenheit. To keep the pistons from melting and to protect the catalytic converter downstream, the engine needs to dump extra fuel into the cylinders. This extra fuel acts as a liquid coolant, lowering combustion temperatures and shielding the expensive precious metals inside your exhaust. But here is the catch. Ford doesn't want you to know. to cheat the emissions tests and keep fuel economy ratings inflated on paper. The factory programming includes a deliberate time delay before it allows the engine to enrich the fuel mixture. The computer artificially forces the engine to run lean under high load for as long as 10 to 15 seconds before finally stepping in to protect the hardware. For those 15 seconds, your exhaust valves and your catalytic converter are being subjected to a literal blast furnace. Now, combine that aggressive, delayed factory programming with an aging upstream oxygen sensor. This sensor is the single most important guardian your catalytic converter has, sitting directly in the exhaust stream to read how much unburned oxygen is leaving the engine. If that sensor is functioning perfectly, it switches its voltage output multiple times per second, allowing the computer to make micro adjustments. But as these sensors cross the 60,000-mile mark, they become lazy. The internal zirconium element gets coated in carbon and oil vapors, slowing its response time from milliseconds to seconds. When a lazy sensor meets that delayed factory fuel logic, the engine control module loses its mind. The sensor gets stuck, reporting a false lean condition to the computer. The software looks at that data and thinks the engine is starved for fuel, so it overrides the delay and commands the fuel injectors to open completely. It starts dumping an absolute flood of raw, unburned gasoline straight into the combustion chambers. This is where the catastrophic chain reaction begins. That massive volume of excess fuel cannot burn completely inside the cylinder. It exits the exhaust valves as a raw mist, traveling directly into the ceramic honeycomb substrate of your catalytic converter. Your converter is already screaming hot from the factory's delayed cooling strategy, operating right at its thermal limit of 1600 degrees Fahrenheit. When that raw gasoline hits the white-hot platinum and palladium layers inside the converter, it doesn't just pass through. It ignites inside the exhaust pipe. Your catalytic converter instantly stops acting as an emissions filter and transforms into a secondary combustion chamber. The internal temperatures don't just climb, they spike exponentially, soaring past 2,000 degrees and pushing toward 20,500 degrees Fahrenheit. The structural integrity of the ceramic honeycomb completely collapses. The thousands of microscopic channels designed to let your engine breathe begin to sag, warp, and literally liquefy, fusing together into a dense, solid brick of melted glass. Let me tell you exactly what this looks like in the real world. Because I had an F-150 with the 3.5-liter EcoBoost towed into my shop just last month that perfectly illustrates this nightmare. The owner was pulling a moderate load on the interstate when his check engine light started flashing, which is the computer's universal code for stop driving immediately before you destroy something. He figured he was close to home and could make it. Within 10 miles, the truck completely lost power. It wouldn't accelerate past 30 miles per hour. The floorboards were radiating intense heat, and the engine eventually stalled dead on the shoulder when it arrived at my bay. I hooked up my diagnostic tool and saw a string of P0171 and P0174 system lean codes, immediately followed by catalyst efficiency codes. I walked under the truck, dropped the downpipes, and used a borescope to look inside the converter housing. What I saw was absolute devastation. The internal ceramic substrate hadn't just cracked, it had melted into a green, glassy puddle that completely plugged the exhaust pipe, cutting off over 90% of the engine's airflow, because the exhaust gases had nowhere to go. The back pressure backed up directly into the turbochargers and the exhaust manifolds. The intense, trapped heat warped the cylinder head, blew the head gasket, and cooked the exhaust valves on cylinders 3 and 6. A failure sequence that started with a degraded sensor that costs less than a fast food meal ended up destroying the entire upper half of the engine. The total repair bill for a new cylinder head, gaskets, turbo hardware, and a factory OEM catalytic converter came out to just over $5,400. All because the factory programming allowed a lazy sensor to dump fuel until the truck choked on its own melted components. The most frustrating part of this failure pattern is that the average driver has no idea it is happening until the dashboard starts flashing and the power drops. As the sensor degrades over thousands of miles, your fuel economy will slowly plummet as the computer runs richer and richer to compensate for the bad data. You might notice a faint rotten egg or sulfur smell coming from the exhaust when you park. That is the precious metals inside your converter literally crying for help as they are overwhelmed by unburned fuel. You might see wisps of black smoke from the tailpipe under hard acceleration. These are the early warning signs that your factory settings are actively cooking your exhaust system. If you ignore these signs, the financial cascading effect is brutal. On a modern Ford SUV or truck, replacing just the catalytic converter can easily run you $1,500 to $2,500 depending on your engine layout. If you drive an EcoBoost, where the converters are tucked tight against the turbos, the labor alone will make your eyes water. And if that thermal meltdown warps your exhaust manifold or destroys your downstream monitoring sensors, you can easily tack on another $1,000 to the bill. You cannot rely on the factory software to protect you from this outcome. The vehicle's computer is programmed to trust its sensors until they fail so catastrophically that they trip a hard diagnostic code. But by the time the light stays on permanently, the melting process has already begun. To prevent your Ford from becoming another expensive statistic in my shop, you have to take control of the hardware management yourself, because there are even deeper, more restrictive factory traps waiting to catch you off guard if you don't know where to look. We have already exposed how the auto start-stop logic slowly grinds your bottom-end bearings to dust, and how the factory's delayed fueling strategy combines with a lazy sensor to melt your expensive exhaust system into a solid block of glass. But those two settings are still reactionary. They deal with mechanical stress after the engine is already running. There is a third factory calibration hidden deep inside Ford's powertrain control module that is arguably the most deceptive of them all. It is a setting that acts from the very millisecond you start your vehicle, and it is actively accelerating the mechanical wear of your entire valve train every single morning. I am talking about the factory-programmed high RPM cold start strategy, specifically paired with the oil pressure control logic on variable displacement oil pumps. When you start your Ford after it has been sitting overnight, you probably notice the engine immediately flares up to 15,500 or even 18,800 RPM. To the untrained eye, this seems normal, just a cold engine warming up. But as a mechanic, watching a freezing, unlubricated engine instantly scream to high RPM makes my stomach turn. Ford programs this aggressive flare into the software for one reason: to light off the emissions equipment as fast as humanly possible to meet strict cold start tailpipe regulations. The computer purposely retards the ignition timing and ramps up the engine speed to dump massive amounts of heat into the exhaust manifold. The hidden danger here is that during those first 5 to 10 seconds of a cold start, your engine is at its absolute most vulnerable. The oil has completely drained down into the oil pan, leaving the overhead camshafts, the roller lifters, and the timing chain guides bone dry. To make matters worse, modern Fords use a variable displacement, computer-controlled oil pump. Unlike an old-school mechanical pump that builds pressure directly proportional to engine speed, this factory setting allows the computer to step in and artificially restrict oil pressure during startup to reduce parasitic drag on the crankshaft. Think about the mechanical violence happening inside your valve train during this event. Your engine speed is forced to nearly 2,000 RPM, while your oil pump is commanded to provide minimal, economy-focused pressure. The hydraulic timing chain tensioners lack the fluid pressure needed to keep the heavy timing chains taut. The loose chain slaps violently against the brittle plastic guide tracks. At the same time, the dry camshaft lobes wipe directly against the roller finger followers without a proper pressurized film of oil. This daily metal-on-metal slamming is exactly why we see so many EcoBoost and Coyote engines developing the dreaded cold start rattle by 60,000 miles. By prioritizing immediate emissions compliance over mechanical lubrication, this factory setting actively shortens the life of your timing components, leading to a massive $3,500 valve train rebuild down the road. Now, take a step back and look at the big picture. When you combine all three of these factory settings, the auto start-stop bearing abuse, the delayed fuel cooling that melts catalytic converters, and the dry high RPM cold start logic, you begin to see a pattern. Your vehicle was engineered by brilliant minds, but those minds were shackled by corporate mandates to prioritize fleeting efficiency scores over long-term durability. If you leave your vehicle exactly as it came from the factory and follow the dealership's hands-off advice, you are blindly walking down a path toward catastrophic mechanical failure. But you do not have to let these factory settings dictate the lifespan of your vehicle. You can outsmart the software by implementing a cohesive, proactive prevention strategy that resets the balance back in favor of mechanical longevity. First, take control of your vehicle's software logic. Invest in a reputable OBD2 programming tool or electronic bypass module to permanently disable the auto start-stop system. Do not settle for pressing the button every time you drive. Remove the command entirely so your engine bearings never suffer from zero-pressure restarts at a stoplight. While you are at it, consider a custom powertrain calibration from professional tuning house that deletes the catalyst over-temperature time delay and modifies the cold start strategy. By commanding the fuel injectors to enrich the mixture immediately under heavy load and lowering that aggressive morning idle flare down to a stable 1000 RPM, you insulate your catalytic converter from thermal meltdowns and protect your dry valve train from cold start friction. Second, rewrite your maintenance schedule based on physical shop floor reality, not corporate marketing brochures. Toss the factory 10,000-mile oil life monitor out the window. Change your oil every 5,000 miles or 6 months on the dot, using only top-tier full synthetic oil and an OEM filter with a high-quality silicone anti-drainback valve. This frequent schedule prevents fuel dilution from shearing your oil's viscosity, ensuring your timing chain always has a thick, protective cushion. Additionally, treat your upstream oxygen sensors as a preventative maintenance item. Do not wait for a check engine light to tell you your converter is already melting. Proactively replace both upstream sensors every 80,000 miles to ensure the computer is always making fuel corrections based on fresh, rapid data. Finally, change how you operate the vehicle to mitigate these hidden software traps. When you start your truck or SUV in the morning, do not immediately drop it into gear and drive off while the engine is screaming at 1,800 RPM. Wait 45 to 60 seconds for the computer to naturally drop the engine's speed down to its base idle and allow the variable oil pump to fully stabilize fluid pressure throughout the entire block. When you are out on the road towing a heavy load, avoid long, sustained periods of wide-open throttle in high gears. If you need to pass or climb a steep hill, manually drop the transmission down a gear or two using the shifter buttons. This forces the engine RPM up, increasing mechanical coolant and oil flow, while reducing the lugging stress that triggers the factory's delayed. Dangerous lean burn logic. The difference between a Ford that hits 300,000 miles on its original internal components and one that ends up on a flatbed bound for my shop comes down to ownership education. The factory settings are a baseline meant to satisfy regulators. But as an insider who has seen the exact same preventable failures hundreds of times, I know that true vehicle longevity requires you to step in where the manufacturer left off. By taking control of your software, tightening your maintenance intervals, and operating your hardware with mechanical sympathy, you can completely neutralize these hidden dangers. If you found this insider breakdown valuable and want to keep your ride out of the repair bay, go ahead and smash that like button right now. Hit that subscribe button and click the notification bell so you never miss another deep dive mechanical expose. Drop a comment below and let me know, have you experienced cold start rattle or a flashing check engine light on your Ford yet? Share this video with every truck and SUV owner you know, because giving them this information right now can literally save them thousands of dollars in catastrophic repair bills. Thanks for watching. Keep your oil clean, and I will see you on the shop floor.